Let's suppose we have two numbers, x and y, such that their square roots, so the square root of x and the square root of y, are very close to each other. So that would mean that when you subtract one from the other, you're going to get around zero. About zero. Because when they're exactly zero, then that means the square root of x, and then add square root of y to both sides, equals the square root of y. But they're not entirely equal, which is why we use this sign, not the equals sign. So now let's suppose we square both sides. Obviously on the right hand side we'll still get 0, but on the left hand side we're going to get x and then a plus y, and then we're going to get a minus 2 times the square root of x times the square root of y. So minus 2 times the square root of x times the square root of y. And again, that's about 0. So now let's do this. Let's add the 2 times the square root of x times the square root of y on both sides. So now we have 2 times the square root of x times the square root of y is around x plus y. And now divide 2 times the square root of y on both sides to get the square root of x is around x plus y divided by 2 times the square root of y. Now what does this equation show us? Well, there's a really good application here in that if you want to find the square root of some number but it isn't a perfect square, such as let's say 23, all we have to do is find a perfect square close to 23 and then calculate this over here. So for instance, what's a perfect square close to 23? 25. So let's plug in 23 for x and 25 for y in this equation. We get 23 plus 25 divided by 2 times the square root of 25, which of course is just 5. You get 48 divided by 10, or 4.8. So we're saying that the square root of 23 is around 4.8. Now, in reality, the square root of 23 is actually equal to 4.7958, ... But that's pretty close to 4.8. So this equation right here, the square root of x is around x plus y divided by 2 times the square root of y, is actually very useful when you want to find the square root of a non-square number. And we are done.